Hello, these are day 3, problem 1.3, individual practice problems. I'm going to go through some solutions. Now remember, in math, you may arrive at the answer a little differently than your teacher or your mom and dad. That's just fine. So here's the first question. It was number 16. It says, Dwayne and Todd are playing the product game. Dwayne has the blue chips, so I wrote that here so we can remember. Dwayne is blue and Todd is red. Todd is red. The paper clips are on 5 and 6, so 5 and 6, and it's Dwayne's turn to move the paper clip. So it's Dwayne's turn. And what we're going to be doing is we need to see which moves would allow him to block Todd from getting 4 in a row. So first, let's go see where there's some possibilities that Todd might score. So Todd could score 42. So it says which moves would allow him to block Todd from getting 4 chips. So 42 is where Todd might put a red. So we have to be able to look at these two factors and determine which one of them we should move in order to block Todd at square 42. So should we move the 6 or the 5? Well, if we move the 6 to any of the other factors, there's no number times 5 that would give you 42. So we obviously have to move the 5. And where would we move the 5? We would move this 5 right here. We'd move it over here to, I'm going to do this in, oh, I should do it in blue. We should move it over here to the 7. So we need to move that to 7 because 6 times 7, 6 times 7 equals 42. These are factors that give you the product of 42. These are also divisors that go into 42. So 6 times 7 is 42, and that means Todd, I should do a highlight here, Todd, excuse me, Dwayne would block with a blue. Let's go to the next question. It says list 4 multiples of 3 that are not on the game board. So multiples of 3 that are not on the game board. Well, let's first go through and find all of the multiples. Let's do it in green. The multiples of 3 that are on the game board. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 9 is 27. 10 times 3 is 30. 11 times 3 is 33. Well, there's one right there. 33 is not on the game board. Okay, 33 is not on the game board. 12 times 3, is that on the game board? A 36. 12 times 3 is 30. Yeah. Oops, I should have used a marker. 13 times 3, and so the numbers get a little bigger. You can start saying, okay, what's 13 times 3? 3 times 3 is 9. Oop, don't carry anything. That's a 9. 3 times 1, 3 times 1 is 3. 39. So is 39 on the game board? Nope, don't believe so. So 39. Let's find one more. 13. Well, it's 13 times 4. 4 times 3 is 12. 4 times 1 plus 1 is 5. So there's another. Hold on for a second. I did 13 times 4. We should have done, excuse me, I don't like that. Let's use black. We should have done 14 times 3. 4 times 3 is 12. 42. Is there a 42 on the board? No, there's not. There is no 42. And it's really an infinite number. So ... is an infinite number. But those are just 3. Sorry about that little mistake, but that happens. Moving on. Number 18. What 4 factors were used to make this product game board below? All right, so we have to figure out, I'm going to make this a little bigger for us, which 4 factors made this game board. For problem 18, it says, what four factors, and they'll go here, what 4 factors were used to make this product game board below. So what numbers multiplied by another number would give you a 9, 21, 15, 18, 30, 35, 36, 42, and 49? Well, it's kind of a tricky problem. But what you can do to figure out the factors, let's first find the factors. Hey, this is good practice. Let's find the factors of each of the numbers listed on the board and see if some of the factors match. So I'm going to do that, and I'll do 9. And I know that 9 is 1 times 9. 15 is 1 times 15, 3 times 5. 18, let's see, 1 times 18, 3 times 6, 2 times 9. I think I've got them. Let's do 21. 1 times 21, 3 times 7. This is great practice. 30. 30 is a whopper. 1 times 30, 2 times 15. I have to go over here. 3 times 10. 5 times 6. Did I get them all? I think so. 35. 1 times 35. 7 times 5. 36. 1 and 36. I'm going to pause the video while I finish the rest of these, and then we'll come back. All right, so I wrote out the factor pairs for each number. For each number up there. Now, to figure out which factors go into making the board, we have to figure out which factors made all of these numbers. So a lot of these factors don't come into play. So if we think about how we would make 9, and I missed one right off the bat, 3 times 3. Let's find common ones. So I'm going to circle the ones, or let's say I'm going to highlight them in yellow, the ones that are common. So I see 9 has a 3, 15 has a 3, all of the ones that have a 3. Let's go through and do that. 3 and 3. All right, those are my 3s. So let's see if we can use 3 to make some of these numbers on the grid. 3 times 3 is 9. 3 times 5 is 15. 3 times 6, 3 times 7, 3 times 10. Not one for that. 12 times 3, none, none. Okay, so let's just temporarily say 3 is probably one of the factors. Oh, I'm going to do that in black. All right, now let's see if we can find another one that's common. How about 5? I'm going to highlight, let's highlight green. Let's see 5. So 15 has a 5. 30 has a 5. 35 has a 5. So 5 is most likely one of the factors. Oh, that's not good. I got to erase that color. Got to go back to this. Any other common factors? Let's see. 6. Let's see. 6, because how else would we make 18? Let's see. Who's got some 6s? And let's do that in blue. There's a 6. Oops. There's a 6 here. There's a 6 here. There's a 6 here. And there should have been a 6. Oh, there's one. A 6 here. So 6 looks like it might be, oh, I like black, might be a factor. And then as I look at some of the other ones, let's see, let's do the highlight. I used blue, yellow, let's use red. How about 7? Let's see if 7, okay, there's a 7 in 21. There's a 7 here to make 35, and there's a 7 for 49. So maybe 7 would be good. Now, I don't know if there's really a simple way to do this problem other than just to make sure that we're doing it correctly. Now look, let's see if we can make 9 using these factors. Let's see if we can make a 9 or every single number in this grid by using these factors. Let's try it. How do you make 9? 3 times 3. How do you make 15? 5 times 3. How do you make 18? 6 times 3. How do you make 21? 7 times 3. How do you make 30? 6 times 5. How do you make 35? 7 times 5. How do you make 36? 6 times 6. How do you make 42? 7 times 6. How do you make 49? 7 times 7. All right, awesome. Those are the factors. Now, the hardest part here is which product is missing? This one right here. I'm going to make that one red. Which one goes here? Well, I thought this was a good problem because if you look, there are some square numbers that I'm going to highlight in yellow. Square means a number times itself. 9 and 49. So what would go here? Well, how about 25? 5 times itself would be 25. 5 times itself would be 25. And that's the product that goes in that hole. It's kind of a tricky problem, I know. All right, let's do the last one. Allie's aunt has saved $10,000 in $20 bills. She spends one $20 bill every day. How many days will it take her to run out of bills? So if you have a pot of money, a pot of cash that's $10,000, I'd like to have that. And you're going to spend $20 every day. $20 every day. How many days will it take her to run out? So aren't we really saying how many $20 go into making 10,000s? All right, so you do the math. So the dividend is 10,000 and the divisor is 20. So 10,000 divided by 20, let's walk you through it. 20 does not go into 1. 20 does not go into 10. 20 does go into 100. 20 times 5 is 100. All right? Drop a 0. 20 does not go into 0. It goes in there 0 times. 20 times 0 is 0. Drop another 0. 20, does it go into 0? No. So, 20 times 0 is 0. We have a 0 remainder. So, if we say 500 times 20, shouldn't we get 10,000? Well, let's do this. Let's see. 500, that would be days, at $20 per day. Here's a little trick. If you do 5 times 2, you get 10. Oop, 10. Where's my eraser? 10. And then we can add the zeros that we have remaining on. 1, 2, 3. So let's do that. Let's do that in green. 1, 2, 3. So 500 days at $20 per day would give us our dividend, which is $10,000. So that's simply a division problem. I hope this video helps you. You can rewatch it. You can come ask me if you don't understand. I went pretty quick. 18 was quite tricky. This one right here. Thanks for listening.